Hello my dear students, welcome back to the another video in the chapter of this electric charges and fields. That is, we are going to discuss about electric dipole in this particular video. Okay, so what is meant by an electric dipole? Okay, dipole means it is two equal and opposite charges or unlike charges. Okay, unlike charges means one will be positive and other one will be negative. This two equal and unlike charges, if they are separated at a very small distance from each other, okay, the separation between those two charges we are going to take it as very small. Such type of arrangement of charges we call it as electric dipole. Okay, so the distance between those two charges I am taking it as 2L. Okay, I am taking it as 2L. You might be getting a doubt why 2L instead of only L. Okay, that you will be coming to know in the upcoming parts of this electric dipole concept. Okay, so once again, what is meant by an electric dipole, my dear? It is two equal and unlike charges separated by a very small distance. We call it as an electric dipole. So where do we find these electric dipoles in our day-to-day life means? For example, you might be knowing this NaCl, right? Okay, NaCl molecule if you take, it is like a sodium positive ion and Cl minus. These both are at a very small distance. They will be separated to each other. So this NaCl, it is a kind of dipole. Okay, otherwise you can take it like HCl or maybe HF, hydrogen fluoride. It will be H plus and that is F minus. Positive charge, negative charge, both are equal and opposite. So this one we call it as an electric dipole. So regarding this, let us try to move forward in this. So generally, every electric dipole, it will be having a characteristic property. This dipole, it will be having a characteristic property, or we can identify the different properties of this or different characteristics of this particular dipole using a quantity called as dipole moment. Okay, the characteristics of this dipole that can be obtained from a physical quantity called as dipole moment. So what is meant by this dipole moment? Generally this dipole moment we are going to represent in physics or in our concepts with a symbol of P vector. Okay, it is equal to, it is mathematically or definition wise, it is equal to the product of, it is a product of charge with the separation between the two charges, Q into 2L, Q into 2L. So Q into 2L, and of course if you see here, you are able to identify that P is a vector quantity or the dipole moment is a vector quantity. Vector quantity means it will be having both magnitude and as well as direction. The direction, magnitude is Q into 2L, direction is given from negative charge to positive charge. What is the direction, my dear? Negative to positive. Okay, negative to positive. Sometimes this can also be written as Q into 2L vector, where this vector direction is from negative direction to positive direction. Is that okay? So what is the formula for dipole moment? It is the charge multiplied with 2L. It's a vector quantity. Its SI unit is charge SI unit is coulomb multiplied with length SI unit is meter. Once again, why did I take it as only 2L? I'll tell you later. Okay, right. Next, there is another unit for this which we call it as practical unit, which is used for this dipole moment. It is nothing but debye. It is a debye. What is meant by 1 debye means it is equal to 3.33 into 10 to the power of minus 30 coulomb meter. 1 debye, it is the 3.33 into 10 to the power of minus 30 coulomb meter. Okay. So these are the points regarding, basic points regarding the electric dipole. And one more thing, dimensional formula. Dimensional formula of this is, charge is having a dimensional formula of a power 1 t power 1. Length is having a dimensional formula of L power 1. If I rearrange this, you will get it as m power 0, L power 1, t power 1 and a power 1. This is the dimensional formula for electric dipole. Okay. So for example, look at this. There are three charges, like for example Q, minus 2Q and as well as Q. Okay. These charges, they are arranged this way such that the line joining these charges individually, they are making an angle of 60 degree to each other. Okay, 60 degree to each other. Now, what is the electric dipole moment of this particular system? Okay, let us take this particular distance is A. Okay, what is the dipole moment of this system? Let us see once. Now here what I am going to do is Q, let it be like that. But here whatever this 2Q is there, I am going to divide that into two parts. Okay, and this is again Q, right? So when I divide that into two parts, I think now you are able to see it like two dipoles. One is going this way and another one is this way. Is that okay? This is A and this is also A. Now these both dipoles are at what angle to each other? 60 degree. So look at this. Dipole moment of each pair. Okay, let us take this is P1 and this is P2. Okay, as the distances and the charges are also same, P1 is equal to P2 is equal to charge multiplied with separation between the two charges, Q into 2L, right? Here the 2L value is nothing but A. Okay, P1 and P2, what is their magnitude? Q into A. If you want to find what is the, now here if you observe this P1 vector and P2 vector, both are at an angle of 60 degree to each other. So according to resultant formula, resultant of two vectors. Okay, so here this is also vector, no? Dipole moment is a vector. So we have to find the resultant, which is P1 square plus P2 square plus 2P1 P2 cos theta, cos 60, because these both are at an angle of 60 degree. So it will be equal to root over QA whole square plus QA whole square plus 2 P1 and P2 are equal, right? QA into QA, cos 60 is 1 by 2. 2 and 2 will get cancelled. If you observe this, QA whole square plus QA whole square, it will be equal to root over 3 times of QA whole square. It will be equal to QA into root 3. So final, what is the resultant dipole moment there? It is equal to root 3 QA. So that is how you can find what is the dipole moment of this particular combination. So the next one, in the next video, we will discuss about electric field due to this dipole. Okay, hope you have understood this. Just once again you can stop here and there and then you can go through that point once again, if I have gone little bit fast. Okay, let us meet it in the next video. Thank you.